Hello and welcome to this presentation. I am Jonathan Hill. I am a computer engineer student at Colorado State University. This is for ECE561, which is Embedded Systems class. I am going over my baseball cap LED music visualizer presentation right now for my project that I have done over the semester. So let's get started. So a brief introduction of the project. I wanted to build a LED music visualizer that could be mounted on top of a everyday baseball cap. The reason I wanted to do this was to take it to music concerts. I am a huge fan of electronic and EDM music, and I enjoy going to concerts, and I thought that a cool thing to have to go to these concerts would be a hat that had a bunch of cool dancing LEDs on top of it. And so that was why I chose to do this for my project. I knew that I wanted to have the RGB LEDs for the project just to add more color and variety so it wouldn't be so stale. And I also knew that the design would have to run for at least 2 hours on its own independently. Since again I would be taking it to concerts, I put that constraint on the design of the system. So when I first started, I knew I had to assemble my parts before I got started. And then the main part component of the whole design is the microcontroller. I decided to use an Arduino Uno, primarily because I already owned an Arduino Uno, and I knew that it would be small enough to fit on the bill of a baseball cap, and since I already owned it, it would be cheap, but also because it would do everything that I needed it to do for this project. The Arduino Uno has 6 analog ports as well as 14 different digital ports, I believe 6 of which are PWM enabled. And so I went ahead and used the Arduino Uno for my project since it was a perfect fit for what I needed it to do. The next part that I needed to purchase would be a microphone, since I wanted this music visualizer to be picking up music in real time and visualizing that on the LEDs. And so when I first started looking at microphones, I came across the SparkFun sound detector, and I knew that this would be a good one mainly because of the envelope pin that it has on there, which outputs the amplitude of the sound that it is picking up as a analog output, and this would be a value between 0 and 255, I believe. And so I knew that I could use that envelope pin very easily to get the information that I wanted from the music, and then be able to output that directly onto the LEDs. And so that was the microphone that I ended up using. And finally, I needed to buy some RGB LEDs, and this was a hard part of the project. One of the hard parts of the project was to try to find what type of LEDs to use, since I wasn't sure if I would have to be writing to 50 individual LEDs. When I first started, I wasn't sure how I was going to do that. And then I came across what's called these addressable LED strips. And what these enable you to do is just hook up a VCC and a ground, and then also a single data pin that will travel across the entire strip. And if you include and download a library in your Arduino code, you can actually set up one of these strips and write to individual LEDs their RGB values, just as if they were part of an array. And so I know that this would be very simple to accomplish what I needed to do for my project. And so I picked up one strip of these, which is a meter long, and it has 60 LEDs, and so they're fairly closely spaced together. They're less than an inch apart, each of them, and so I knew that they would work really well for what I needed to do. So then I began assembling the whole circuit on top of the baseball cap. And so what I started out was soldering jumper leads onto the LED strips themselves. I soldered some wires onto the microphone so that I could plug it in directly to a breadboard that I was using, and I also soldered the leads onto a battery adapter that I would be using. And then I assembled the circuit completely onto the bill of the cap. I ran the jumper wires from the Arduino onto the breadboard, and then from the breadboard back to the LED strips and or the microphone. And then finally I just glued the LED strips onto the baseball cap, and that was the entire setup for the hardware. And this is what the final setup looks like. So on the left picture there, on the left is the Arduino Uno that you can see. I'm only using 2 of the analog pins, one for the envelope input from the microphone, and then one that is writing out to all of the LED strips. You can see there in the middle on the breadboard, there is the breadboard that it is controlling all of the LED strips, and also mounted on top of that is the microphone. And then to the right there is the battery that powers the entire system, which is just a standard 9-volt battery. And then on the right picture, you can see sort of more my LED strips set up. I knew I wanted to run at least 6 along the seams of a baseball cap, and that's what I ended up doing. So I only had three strips, but each of the 3 of them ran also to the back side of the hat, and so I was able to create almost 6 separate LED strips that I would be writing out my data values to. So then I began developing my software, and this was the bulk of the development time went into the software development. Real briefly though, the way that my code works is it reads in the amplitude value from the microphone, and again, that is an analog read. It outputs a value between 0 and 255, and so I just started from 0, and I said if the value is greater than 20 or so, or something, if you will, I would set the bottom LEDs for each of the strips to be on. And then again, I would just check if it was also greater than 40, I would set the next one to be on, and so on and so on. And that was how I turned on the appropriate LEDs based on that value. And then I would also, later on in the project, in the code development, I wrote a function that just cycled through the different LED colors, and you'll see that in a video just in a little bit. But what it does was it took control of 3 just global variables that I would be using for the red, the green, and the blue data values, and it would cycle them through each iteration of the loop. And on that note, each iteration had a delay of 30 milliseconds, and so that was how I set a data rate of slightly over 33 hertz, right, for the refresh rate of the LEDs and the microphone, which turned out to be great, as you'll see soon. So this was what the whole finished system looked like. Again, that's with in idle mode. All of the bottom LEDs are lit up, and then from there it lights up more. And so here, as you just saw, hopefully, is just a quick demo of music running and how the LEDs are actually responding to it. As you can see, it does function quite well in terms of the music is playing and the LEDs are responding in real time. Very quick refresh rate, which turned out to be great. There was no delay that I could visually see between the music playing and the LEDs flashing, and the colors was also changing, although it does change very slow. I'm not sure if you were able to see that in the video. So after I finished the whole system, I began testing. A few things that I wanted to test were to make sure that it was comfortable to wear still, which was huge because I wanted to be able to wear this out in a music concert, right? And I ended up wearing the hat for 30 minutes just around the house, and it was totally fine. Although there was a little bit of extra weight on the bill, it wasn't too much, and so that was great. The battery life, I ran just a quick battery test, and it the battery ran for about 3 hours and 7 minutes or so. So it was well over 2 hours. It was over 3 hours, which turned out to be great. Then I also wanted to test real quickly just the stability and the durability of the components, since I again wanted to take this to concerts. I knew that it would have to be durable, and which it was. Everything stayed in place perfectly. So finally, some future work that I want to put into this project would be to get a new Arduino, possibly a smaller one. Arduino makes what's called a LilyPad, which is a microcontroller that is built specifically for wearables, and it is you can sew on the LilyPad directly onto fabrics, and then also use conductive thread to run your circuits, and so it would be a lot more, you know, more compact on the bill and take up a lot less space. So that would be the first thing. The next thing I wanted to do would be maybe update the color cycling code just a little bit, maybe add some more modes of color changing or dancing LEDs, that type of stuff, just to be a little more flashy. And then finally, and one of the bigger projects that I want to do would be to create a frequency splitting visualizer. And what this would do, I would want to build a couple of bandpass circuit filters to filter out different bands of music, for example, bass or your treble, and then have different visualizers for each of those. But in conclusion, I believe that my project works exactly as I wanted it to, and thank you for listening to this presentation.